I'm here with
J.R. Boisclair
of
Wham Engineering Wally Tools.
Okay.
All right. So I was talking to you about the subject of our first submission that we will hopefully be completing very soon. That will be submitted to the Journal of Audio Engineering Society. It's on the subject of zenith error. And zenith error is the relationship between this contact edge, which is a fine line contact edge on this your stylus, and the cantilever. Okay, now we always presume that the relationship between this line and the cantilever is a perpendicular one. There's perpendicularity. But of the three manufacturers that make these units, we know from the two of them, the third one is a little bit more opaque. The two of them have a tolerance of plus minus 5 degrees. Now, when we align our cantilever,
and you told me that you've seen them off as up as much as 17 degrees.
Yes, but that doesn't keep me from seeing 10 degrees, 14 degrees, as much as 17 and a half degrees off.
Right.
Regardless of the cost of the cartridge. Yeah. There is no direct relationship between them. Now, but industry standard is plus minus 5 degrees. When we align our cantilever at the null point, we're trusting that there is a perpendicularity here because it's this line that matters, the contact line. It's not the cantilever, it's the contact line. So the subject of the paper is we used two different engineering software programs to understand what happens when zenith error exists, and mathematically understand what are the distortions that are created. And I can show it to you with this 1001 scale model. This is a 1001 scale model of a horizontally modulated groove, which is simply the center image, right? And this is a sine wave, okay? Simple sine wave. So when the stylus is properly oriented in the groove, it will travel left, right, just like it's supposed to. Hopefully you can see that. Nice and easy, left, right. However, when a zenith error is introduced, watch what happens now. And I'll go slowly so you can see this.
Oh, yes.
Did you notice?
Yes, of course.
It's going up and down and left and right now. Now there's a vertical component. You see that vertical component? Are you able to see that?
Yes.
All right. So there's a vertical component is forcibly introduced. There is no vertical content in this groove, right? But of course, any movement in the vertical or horizontal plane axes with a stereo cartridge is going to throw off an electrical signal. So what does this mean? It doesn't mean that if the zenith error exists, that it's going to sound bad. It doesn't mean that at all, that it's going to sound bad. What it means is that it's a mechanical certainty that you will get less information out of the grooves.